Hi all, in this video I will show you how to build an advanced n8n automation that creates viral point of view shots videos automatically. This workflow generates immersive first person perspective videos from concept to upload, all running on autopilot. Check out the links in the description if you would like to get all the resources used to build this workflow. This is the POV shots automation workflow. As you can see, this sophisticated system starts with a scheduled trigger that fires automatically based on your schedule, pulls video topics from a Google Sheet, generates hyper-realistic POV prompts using AI, creates stunning images, converts them to videos, adds background music, adds text overlays, then combines everything and finally uploads finished video directly to YouTube. Let me show you the Google Sheet which we populate with video topics. You can use ChatGPT to come up with the video topics and then update this Google Sheet. Here we have the first column as ID, which is just a number. And then we have the idea, which is the main prompt idea. Then we have the caption column, and then we have the production column that has different values. For production means it is ready for the video generation. Then we have the environment prompt. Then we have the publishing column. Make sure to upload this Google Sheet template into your Google Drive and update the topics as per your requirements. Download the n8n template I provided in the description before you start building the workflow. I will show you how to import the downloaded template. First, log into your n8n account. Once you are in the n8n canvas, click on this plus sign and select workflow option. Click on the three dots here and select import from file option. Navigate to the directory where you saved the template file. Select the template file and click on this open button. You can see the workflow has been imported. I have divided the workflow into different sections for clarity. Here we have the video topics section. We start with the schedule trigger node that runs automatically at set intervals. The purpose of this node is to automatically start the entire video generation process without any manual intervention. In the trigger rules, we have specified the details here, which allows the workflow to run automatically at these specified time intervals. You can adjust this based on how frequently you want to generate new videos. Next, we have the topics node, which is a Google Sheet integration. The purpose of this node is to pull video ideas and configuration data from a centralized spreadsheet where you can manage your content pipeline. Here in the credential to connect with, you will enter your Google Sheet credentials. If you did not already create the credential, you can refer to the video link in the description. In the resource field, we have specified sheet within document, and the operation is get rows as we are fetching data from the Google Sheet. Then in the document field, we are using from list, and here if you click on this drop down box, it will display the names of your Google Sheets. Let me click here, then select the Google Sheet name from the list. In the sheet field, we have specified from list, and here again you can click on this drop down box. It will display the sheet names in this Google Sheet. Here we have only one sheet. As we can see here, we have this name as sheet 1. That's what we have here. In the filters section, we have set a filter for the production column to only select rows marked for production. This ensures only approved video topics are processed. Let me switch to the Google Sheet. Here we see we have this value as for production. We have this return only first matching rows turned on, which means it will grab one topic at a time for processing. Here we have the generate titles node, which is a LangChain LLM node. The purpose of this node is to take a basic video concept and generate multiple detailed POV scene descriptions that will become our video segments. In the source for prompt field, we have selected define below, and we will be specifying the prompt here. This field contains the JavaScript variable that pulls the idea from the topics node. The require specific output format toggle is turned on, which allows us to structure the AI output properly. In the chat messages section, we have crafted a detailed system prompt that instructs the AI to generate hyper-realistic POV image prompt ideas. Click on this corner to make it full window, and here we can see the complete prompt. The prompt tells the AI to create action-driven, immersive prompts that follow a sequential narrative depicting a day-in-life experience. It emphasizes first-person perspective using action-based verbs like gripping, running, reaching, and holding. Next, we have the item list output parser. The purpose of this node is to structure the AI-generated text into a clean list format that can be processed by subsequent nodes. In the number of items field, we specified 2, which means the AI will generate 2 different POV prompts per video topic. For demo purpose, I specified 2 here, but you can increase it to 5 when you generate actual videos. The OpenRouter chat model provides the AI language model for the generate titles node. The purpose of this node is to connect to external AI services through OpenRouter, giving us access to various language models. Here in the credential to connect with field, you will enter your OpenRouter credentials. If you did not already create the credential, you can refer to the video link in the description. In the model field, we selected DeepSeek Chat v30324 free, which provides good performance for free. You don't pay a dime to use this. Next, we will cover this video generation section. We start here with HTTP request node. This node takes our short POV prompts and expands them into highly detailed cinematic image generation prompts that will produce better visual results. In the method field, we have specified post. The URL points to the OpenRouter API for chat completions. In the authentication section, we use HTTP header auth with our OpenRouter credentials. In the JSON body, we send a detailed prompt that instructs the AI to expand the short POV ideas into hyper-realistic cinematic prompts optimized for image generation models. Click on this corner to make it full window. Here is the complete prompt for the image generation. The prompt emphasizes first-person perspective with visible limbs actively interacting with the environment. Next, we have the loop over prompts node, which is a split in batches node. The purpose of this node is to process each generated prompt individually rather than all at once, allowing the proper handling of multiple image generation requests. We are doing this to avoid rate limit errors from Together AI API, which we will use to generate AI images. The AI image generation by Together AI is absolutely free of charge. I made a separate video on avoiding API rate limit errors. You can refer to the video link in the description. Here you see a loop branch that goes through the items, and then here is the done branch that will be executed when all the items are completed. This loop over node ensures each prompt is processed separately, as we have specified the batch size as 1 here. The wait node adds a deliberate delay between image generation requests. The purpose of this wait node is to respect API rate limits and prevent overwhelming the image generation service with too many simultaneous requests. In the wait amount, we have specified 30 seconds delay to ensure stable image generation. Next, we have another HTTP request node. The purpose of this node is to generate high quality images from our detailed prompts using Together AI image generation API. I made a separate video on how to use Together AI API to generate AI images. You can refer to the video link in the description. In the method field, we have specified post. The URL points to Together AI's image generation endpoint. We use HTTP header auth for authentication. We are also sending this header parameter, which is accept, and the value is application/JSON. In the JSON body, we specify the flux.1 Snell free model for fast, high quality image generation. Click on this corner to make it full window so that we can see the complete JSON. This is the model we are using, and here is the prompt. This will be substituted with the value generated from the previous node. We set dimensions to 720 by 1280 for vertical video format with 4 steps for quick generation. In the response format, we have specified URL, meaning we will receive a URL from Together AI API that we can subsequently use in the video generation, and the output format is going to be JPEG. Once all the items are processed, they will be collected in the done branch. Here, the get image URL node, which is a split node, extracts the generated image URL from the API response, so it can be used in the next step for the video generation. In the fields to split out, we have specified data.url, which contains the URL of the generated image from Together AI response. Next, we have generate runway video node. The purpose of this node is to convert our static POV images into dynamic 5-second video clips using RunwayML's advanced AI video generation. I made a separate video on how to use RunwayML API to generate AI videos. You can refer to the video link in the description. In the method field, we are using post. The URL points to RunwayML's image to video API. We use HTTP header auth with runway credentials, and also we are setting the API version header with these header parameters. In the JSON body, we specify the prompt image URL from the previous step. Click on this corner to make it full window, and we are setting the model to Gen3A _ turbo for fast processing. Duration we have specified as 5 seconds. Aspect ratio we have specified as 768 by 1280 for vertical video format. The wait node provides processing time for video generation. The purpose is to allow RunwayML sufficient time to process and generate the video before we attempt to retrieve it. We set 40 seconds here to allow runway sufficient time. Next, we have the get runway video node. This is used to check the status of our video generation request and retrieve the complete video URL when it is ready. In the method we are using get. This get request checks the status of the video generation task using the task ID from the previous step. We have provided our authentication here. The version header parameter ensures we are using the correct value for API compatibility. The next HTTP request node downloads the generated video file. The URL field contains the output URL from the Runway API response. Finally, the read-write files from disk node saves the video to our computer. Keep in mind, this node is available only in self-hosted n8n instances. In the operation field, we specified write files to disk. Here we have specified the file path and the file name. The file name uses a JavaScript variable to create unique file names using the item index. This ensures each generated video has a unique file name. Next, we have video titles section. Here we have the title texts node, which is a code node. The purpose of this node is to extract and organize the generated prompt texts into a format suitable for creating video overlay text. You can just copy and paste this code. You don't need to worry about it. This JavaScript code extracts the text from each generated prompt and creates an array of title texts for later use in the video overlay text. Next, we have the multi-line texts node. The purpose of this node is to format long titles by adding appropriate line breaks so they display nicely as text overlays without being too wide for the video frame. Again, this is JavaScript that you can just copy and paste. Here we can see it splits text into multiple lines when it exceeds 30 characters per line. You can adjust this number based on your requirement. For example, you can make it 25 so that it will display 25 characters on one line. Next, we have prepare text files node where we generate the PowerShell commands needed to create physical text files on the system. The purpose is to prepare the text overlay content in a format that FFmpeg can read during video processing. Again, there is no need to modify anything for you here. When you import the template, all this code will be populated here. As you can see, this JavaScript code creates PowerShell commands that will write the formatted text to individual files which are later used by FFmpeg for video text overlays. Finally, we have the generate text files node that executes the PowerShell commands to actually create the text files on disk. In the command field, we have a JavaScript variable that contains the PowerShell script generated by the previous node. This will create the actual text files that will be overlaid on the videos. Now let us look at the video music section. The purpose of this HTTP request node is to generate ambient background music that matches the mood and setting of each POV video scenario. We will use ElevenLabs to generate the sound. I made a separate video on how to use ElevenLabs with n8n. You can refer to the video link in the description. In the method field, we selected post. The URL points to ElevenLabs sound generation API. Again, we use HTTP header auth for authentication. Click on this corner to make it full window. In the request body, we specify text that describes the ambient musical background needed for the specific POV scenario. The duration is set to 5 seconds to match our video length, and prompt influence is set to 0.75 for good adherence to our description. Next, we have read-write files from disk node. The purpose of this node is to save the generated audio files to disk with unique file names so they can be combined with the corresponding video segments. In the operation field, we selected write files to disk. We have specified the file path and the file name. The file name uses a variable to create unique music files for each generated audio track. Finally, we have combine and upload section. Here we start with the merge node. The purpose of this node is to gather all different workflow branches, which is video, text, and music files, so they can be processed together in the final video creation step. In the mode field, we selected combine, and combine by we selected position. The number of inputs is set to 3 to merge the video files, text files, and music files. Next, we have the execute command node. The purpose of this node is to use FFmpeg to combine multiple video segments, add background music, overlay text, and create a single polished final video ready for upload. I made a separate video on how to use FFmpeg. You can refer to the video link in the description. Click on this corner to make it full window. The execute command node runs a complex FFmpeg command that concatenates the two videos, combines the two audio tracks, and adds text overlays with custom fonts and positioning, and outputs a final combined video file. Here we are joining two video files and two audio files. You can modify this to suit your requirements. For example, if you are combining 5 videos and 5 audio files. The command specifies Arial font, text positioning, timing for when each text appears, font size, and various styling options, including colored text and white background boxes. The read-write files from disk node loads the final video for upload. It reads the completed video file from disk and prepares it for the YouTube upload process. In the file selector field, we use the std output from the FFmpeg command, which contains the path to the final combined video file. Next, we have the upload a video node. It will automatically publish the finished video to YouTube, completing the entire automated content creation pipeline. Here in Credential to connect with, you will enter your YouTube credentials. In the resource field, we have selected video, and in the operation, we have selected upload. The title field uses a JavaScript variable to pull the video topic from the original Google Sheet. We set the region code to US, and we have added an option of privacy status, and we set it to private so you can review videos before making them public. You can also delete this option so that the videos will be published directly. Finally, we have update rows in Google Sheet node. Here we are updating our Google Sheet. We are using the ID column to match the row. Then we are updating the production field to done value, and then we are updating the publishing field for publishing, saying it is ready for publishing. Now we have finished configuration of the entire workflow. We can start testing and see the results. I will run this workflow by clicking the execute workflow button here, you can see the workflow started running. It is in the video generation section now. It finished generation of the AI images. Now they are submitted for the video generation. It generated titles. Now it is generating the music. Now it is combining all the files and uploading to YouTube. We got the message workflow executed successfully. It should have uploaded the video to my YouTube channel. Here you can see our video just uploaded with visibility status set to private. Let me play the video. Here is our video, and here you can see the titles. This is the second title. If you need help building automated lead generations, setting up cold email machines for your marketing campaigns, please reach out to me. If you found this video useful, please like, share, comment and subscribe to my YouTube channel. Let me know in the comment section if there is any specific topic you want to be covered. Bye until next video.